Okay, so I want to go through writing equations from different graphs, and how do we do it, and what the different parts mean and where they come from. Now this should be something that becomes automatic, and you shouldn't be putting a lot of thought into it. So it all kind of stems from what you do in math, except it's useful. The basic y and x values are completely generic in math. They don't stand for anything. It's only going to be applied into either science or money to mean something else. So it's just a form. So when you have this type of graph, you have an equation that is y equals mx plus b. Y equals mx plus b. And then b is the y-intercept. And the y-intercept is when or the value of y where the line hits that axis at x equal to 0. So we're going to call that y, because it's a y value, when x equals 0. So we're going to say it's y sub 0, or y naught. Y is equal to now the slope, m, times x, plus the y value when x is 0. Right? And that's just the generic math equation. Now, y and x are arbitrary. You could easily make this c and b, so that the equation for this graph would be c is equal to m being the slope, b plus the value of c when b equals 0. Still doesn't mean anything because c and b don't have any physical value, meaning. When we put physical meaning to it, such as velocity and time, our equation becomes meaningful. So v, velocity, is equal to the slope times time plus the value of the velocity when t was equal to 0, whenever we started our time. Was the object moving? In this graph, it's showing that it was. Okay. The next thing is, what does that slope stand for? We've done this a lot. So the slope is going to be equal to the change in the velocity, which is the y, over the change in time. And just by definition, we can see that that's acceleration. If we don't know its acceleration, we look at the units. We have meters per second, which gives us meters per second squared. We know its acceleration. So that gets substituted into our original equation, and we get that v is equal to a times t plus v naught. If I just do one quick rearrange, this is a familiar kinematics equation. All right, and it came from the graph and the slope information that we can get from the graph. Make up other physical values. So we have position in time now instead of velocity in time. Well, our equation is now x equals our slope. Our slope is now going to be the change in position over time. The change in position over time is meters per second, so it's going to be velocity times time plus the position that we started with when the time was 0. If we make a couple rearrangements here, we can see that we get the change in position, or displacement, is equal to the velocity times the time. Another familiar equation. So you really just replace the form that you get in math with the specific variables, and then figure out what the meaning of the slope is. We're going to be working with this more throughout the year, so come in with questions. The next video is going to show you what happens if we don't have a linear relationship.